What is a matrix? we're gonna understand row operations, systems equations, row echelon form, and row reduced echelon form. Okay, awesome. So there's like this celebrity, Ryan Reynolds, and he's like these glorious six-pack, chiseled abs, and it's a smoking beauty of Canadian beauty. And it's like, oh, he's going to McDonald's. Yes, 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 yes. And he's on his way to McDonald's, right? As drawn by this line. Oh my God, from 124 Sunnybrook to Lawrence Station. Oh my God, and it crosses paths with Ryan Reynolds. And so now there's like these two lines, and it's like, now I want to, where, at what coordinate position will Ryan be hit, Ryan Reynolds, by the 124 bus? So I can say, well, the path of Ryan Reynolds, this is just given in the question, is it can be graphed by y equals 3x plus 1, and the path of the bus can be graphed by y equals negative x plus 5. And so, intuitively, any logical man would open up their calculator and not actually do any work. And we can see that the intercept is 1, 4. That's where Ryan Reynolds is going to be struck by the bus and not get his McDonald's. And so yeah, we can look at it like that. But like, snap, you have a teacher, and your teacher's a loser. He's like, you can't solve it with a graph. You can't use a graphic calculator on this test, and then they suck. I don't like them. And so your smart self say, oh, well, I remember from class. I'll do a systems of equations. Let's do something like that, right? So we can do by elimination 1, 4. Something I recommend is before we continue on this lesson, I would like you to do this problem yourself. With just elimination. And then so, now we're like, okay, so here's our two equations, y equals 3x plus 1 and y equals negative x plus 5. Oh, but then your teacher, oh my gosh, he's back again. And what does he want? He's like, oh, let's rearrange it like this. And oh my God, it's in a matrix. This is what a matrix is, right? So what I want you to notice is that what has this professor done? Well, he's put our constants to the most right, and he's put all our variables on the left-hand side of the equation. Right, so I want you to see we have these. This is in what you're used to when you're graphing a linear equation, and then it's like this. And then so we put our constants here, and we have our y values. Both of them are 1. So the coefficient on y is what? It's 1. Yes. The coefficient here is also 1, as we can tell. And so I'm going to put 1 and 1 here, right? And then what's the coefficient of x? Well, it's negative 3. So I'm going to put that negative 3 here, and I'm going to put a 1 here. And now we got our matrix form. So then now I want you to understand. Okay, well, why? What's the goal of matrices, right? In principle, we're solving the same thing. We're getting to the same result, and I'll show you later when I solve this that yes, this will equal 1, 4. That's where Ryan Reynolds will be struck. It's a method of essentially solving a systems of equations, structured way of doing it. It's the way computers do it, and it's interesting. But let's first understand what is the goal of matrices. So we're just trying to solve the equations. We're trying to find where they equal. And like some way that I like showing this is that you don't have to understand this right now, but what we're looking at right now is we're looking at a bunch of planes. This is how you actually graph a plane. Maybe I'll do a video if you guys are interested. And so I can graph all these planes here, and I'm like, oh, okay, so at what point do all these planes intersect? And it's kind of funny because it's like so many planes. It's like some idiot teacher's probably asking, how do you solve that? So that's essentially what you're doing. You're trying to find the intercept between a bunch of variables, right? And so, you can be posed with a simple math problem that looks like this, right? We have variables A, B, C, D, E. I mean, usually it's X, Y, Z, but then I don't know what to put after that, so I picked my favorite letters from the alphabet and I put them up here. And then on our right-hand side, we have all our constants. So we can have a matrix in, very wide, very tall, right? But as the rule goes, the amount of unknown variables you have is equal to the amount of equations you need to solve for those variables, right? So if you have 2 unknowns and you need 2 equations to solve it, right? So like these can be used to when we're solving the intersection of planes, right? If we go back to our previous problem, right? Some of these planes, when they intercept, they form a line. Like I want you to look at this blue one and this red plane. They kind of form. If we just ignore everything else, they kind of form. So with this, we can say, oh, okay, is there a unique point of solution? Do 2 lines intersect and form, 1 coordinate, or is there multiple solutions? How many solutions? And that's what matrices are very powerful for. If you want, we can look at the intersection of planes later. But for now, I just want to get the basic idea of how do we solve these. And to that, I didn't I didn't know too much, so I looked up this guy, this beautiful, handsome man. I don't know what the hell all this I do, but yeah. So he taught me how what's row echelon form versus row reduced echelon form. And so basically, what is row echelon form? That's what REF stands for. It's like an abbreviation, so math people can like feel all superior and better than you, even though they're they're just like the same person. Anyways, the goal is that we'll notice that there's like this staircase of zeros. This isn't the greatest example because we have too many columns here, right? Remember how I told you about that? The amount of variables is equal to the amount of rows. So this is not a great example, but let's just ignore these bottom two rows for now. You see that there's a value 1. So the first property, an attribute of reduced echelon form is that all, we try to bring the most left-hand term value to 1, and then below it we have a 0, and below it we have 0. And so essentially what row echelon form is that each preceding staircase, each preceding step, each preceding equation is preceded by an extra 0, right? So we go 1 and then 0, 1 and then 0, 0, 1. But remember, if we look back here, we see that the 7, 6. So, everything past the 7 here can be any number, as I show with the asterisks, right? But what matters is that these are zeros, right? And we also want to get this staircase of 1s. Row reduced echelon form right here is that, okay, this part of the staircase is also zeros. So now I know that x, let's say this variable right here, which I'm pointing at, is x. X is equal to asterisk, x is equal to 1, right? And y is equal to 2, and then z is equal to 3. This is for a unique solution. This is how it would look. And so I came up with this awesome acronym, I think. It's before you think. And so this will help you understand the operations involved, right? So and so yeah, so let's look back at this Ryan Reynolds problem of him getting struck by the bus. First thing I want you to say is that this is what we had on our previous slide, this matrix, right? And so what we do is that we write out the matrix, and then we want to perform an action. This is the notation. We say row 1 to row 2. So we take row 1 and we bring it to row 2. And we take row 2 and bring it to row 1. This is just us essentially swapping it. And so when we write this notation, this means this is what's going to happen in the preceding matrix, right? Not this matrix, in the preceding. So row 1 to row 2, I see these two have swapped. And then row 2 to row 1, I see that these two have swapped, right? So we swap the two. The next one is, remember, in our acronym H, multiply all terms by a constant. We can see that we multiply this row 1 by 3 and plus row 2. And then so, okay, so now this is a 0. We're getting there into row echelon form, right? And then we perform this action and we get to row 2. And then, and we get the answer. But it's also confusing. I don't understand it, is what I said to my teacher, as he just said, your problem, find a video. I can't explain it. It's pathetic. Anyways, so what is the goal? What are we trying to do when we solve a matrix? And so what I want you to look at is like, okay, we got to get the zeros. And what's a pattern I can tell? Oh, well, this is zeros, and then this is 1 less 0, and then 1 less, and 1 less, 1 less, 1 less, 1 less, right? And on and on and on. So what should I do? Well, let's take the first row. I'll take row 1, and I'll find some commonality between the two, right? So commonality between 7 and 4. And what I'm going to do is I'm going to say, let's take this row, we'll take row 2 minus row 1, and such that I can get a 0 in this first column, and then a 0 in the next one, right? So I say, I use row 1 applied to row 2, row 1 applied to row 3, row 1 applied to row 4, row 1, and I go on and on until this entire column is zeros. And so now my next goal is I'm going to take the 6, I'm going to find what's common between 6 and 5, and I'm going to multiply it, by some sort of constant to get 6 and 5 equal, and then we're going to go down and down and down and down and down and down, right? And then we're going to do this again, right? So now the next one's going to be zeros. And then the next one's going to be zeros. And then with this, we get this, now we get the staircase. And okay, so now we got that. Now we can do the other for the opposite side. And we can get it into row reduced echelon form. And that's essentially, in principle, how you're meant to solve these. And I think it's very important that you understand the goal of like how I approach this and how I should solve this. Otherwise, it's very complicated, and you won't understand what the process should be.